From your notes number 6, we had this equation right here for arithmetic sequence. So we have a of n equals a of 1 plus parentheses n minus 1 close parentheses times d, where a of n is our nth term. That's the term in the sequence we would be looking for. A of 1, which is our very first term in the sequence, our term position, and then our common difference, how much you have to either add or subtract each time to get the next term in the sequence. So an arithmetic sequence is skip counting by a common difference d. Use repeated addition or subtraction, which is just multiplication, to find the terms. So the first example, count by d's from 0 to 360. Now we have 0, 15, 30. The common difference here is 15 because each time we add 15 to get the next term. So our d is 15. Our first term is 0. So go ahead and fill in the rest of these blanks. Pause the video. And then unpause to get the solutions. Okay, we're halfway there. 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, 195, 210, 225, 240, 255, 270, 285, 300, 315, 330, 345, and 360. Now to find a of n, we just plug in the other values that we already have. So a of n equals a1, which is 0, plus parentheses n minus 1 times d, which is 15. Now n's domain in this sequence is just the terms from 0 to 360. And if we count the terms, we have 25 terms. So we'll just list that. So we have n equals 1, n equals 2, all the way to n equals 25. And since we know that it's going by ones here, we don't have to write all those numbers in here. We could just put these dots and put the last term. Okay, our arithmetic equation is the same thing as a of n up here. Let's make it a little bit more standard though. So we'll have a of n equals 15 parentheses n minus 1. We don't need to put that 0 there because if we add 0 to anything, it's that same number. Okay, take a couple of seconds. Count by d's from 1 to 21. Also identify what is the d. Okay, from skip counting, we have 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. So if our first term is 1, and a of n in this case is 21, our common difference, we're adding 2 each time. So we basically have a plus 2 each time, because 1 plus 2 is 3, 3 plus 2 is 5, and so on. Now n's domain, we have the first term, second term, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and 11th. And so our arithmetic equation would be a of n equals a1, which is 1, plus 2 times n minus 1. And that's our equation. So from here, in addition to finding numbers in a sequence, we can also find the sum of that sequence. That would be called arithmetic series. Here's the equation for that. So you're basically given our arithmetic equation, and then we plug it in. So a of 1 is if we put in 1 for n. So 2 times 1 minus 1 is 1. A of n would be this last term up here. So 2 times 11 minus 1 will be 22 minus 1. That's 21. N is 11, and so the sum of the first 11 terms of this sequence will be put in like this. N, which is 11, a of 1, which is 1, plus a of n, which is 21, all divided by 2. So we have 11 times 22 divided by 2. Now 22 divided by 2, we'll have 11. And 11 times 11 is 121. So this should be our sum for all of these numbers added together.